Our first lesson in Unit 4 is going to be relatively short because it covers a comparatively uncommon situation that we see in algebra. But it does turn up, and so we do want to cover it. We want to make sure that you've got that background. And that is graphing linear equations in one variable. And the reason why this is uncommon is most of the linear equations that you're going to see will be in two variables, not one variable, but they do turn up. And so we do need to know what to do with them when they do. Now, before we get into that, I want to review the coordinate plane. So I just put a coordinate plane up here. And as a reminder, and this is assuming some background knowledge in the coordinate plane. So if you don't have that background knowledge, you want to make sure that you're really paying attention now because this is when you're going to get it. The coordinate plane is composed of two axes. You've got a vertical axis and a horizontal axis. Pretty much these are just two number lines. So you can think of our number line from the second unit when we were adding and subtracting signed numbers as being this axis right here, and then there's another number line that intersects it. This number line is called the x-axis. It is the horizontal axis, and the vertical number line is called the y-axis. And typically you will see tick marks at the grids and at the little where the boxes are. So these are like hash marks or tick marks, and they are important, and they number the axes. So we have 1, 2, 3, 4, and so forth. And then on the other side, we have -1, -2, -3, and so forth. On our vertical axis, the positive numbers go up, and the negative numbers go down. And so I can't really fit the -1 in there, but we'll do like -2, -3. Now, you don't have to count by ones, although that is the most common thing to count by in a math class. Whenever you're doing application problems, word problems, real life examples, the numbers that you have might not be convenient for counting by ones. So if you're talking about, what was I doing today in my Algebra 2 classes, we were doing an activity where we were talking about like the cost of money, and the money would get up into like $40 or $50. Well, if you're dealing with like $40 and $50 on your y-axis, you probably don't want to count by ones. You could, but probably you want to count by 2s or 5s or even 10s. And you don't have to scale the x and the y-axes the same. So it is possible that you could scale your x-axis by 1s and your y-axis by 5s, which I think is what I encouraged one of my classes to do today. What is important though is that you're consistent. So you have to be consistent in how far apart your tick marks are. And you can tell when you freehand it, and you can even tell it with the grid here, that these tick marks are not perfectly spaced in spite of having the grid. So you want to be aware of that when you're freehanding your graphs, that there's a certain amount of unreliability in them. You also need to make sure that the same distance on your axis corresponds to the same distance between your numbers. So just to give you an example of what I'm talking about, I will sometimes see students do this. They'll do 1, and then they might do 1 and then 5, 10, 15. And what happens there is you've got this space right here that corresponds to 1 unit. This is 4 units, and then the rest of them are 5. And if you do that, then what you'll do is you'll distort your graph, and it won't have the right shape. And there's some flexibility with that, but not a lot of flexibility. So you want to be careful about that. When you are plotting points on your coordinate plane, they come in what are called ordered pairs, and the x-coordinate is always the first number listed, and the y-coordinate is the second number listed. So for instance, if you were going to plot the point 2, 4, it means that you would go 2 across on your x-axis and up 4, and you would locate that point. If you had -3, 1, it means that you would go to -3 and then up 1 like so. And these are called the quadrants. So this is the first quadrant, this is the second quadrant, the third quadrant, and the fourth quadrant. And I did that with Roman numerals in case you're wondering what I was doing there. This point right here is the point 0, 0, and that is also known as the origin. Origin often means like beginning or starting point, so it's kind of the starting point where you'd count from. So when you're plotting these points, you start at the origin and then count that number in each direction. All right. Just a few more just to kind of make sure we're covering the bases. A point like this right there, that would be the point for 0. And then a point on the y-axis, like this right here, might be, what do we have there? 0, negative 3. And so you actually do have points that can be on the axis as well. So what I remember doing with my students when I taught like pre-algebra, and pre-algebra was usually when we covered this, is I would give them like a worksheet and they'd have to basically plot a ton of points just to practice it. We call that in math handling the material and handling the content. This is not complex or anything, but if you don't practice it enough, it kind of drains out of your brain a little bit, and I've seen students get the X and Y axis backwards. I've actually seen the number lines go backwards as well, where people put like negative numbers going to the right and positive numbers going to the left. I haven't quite figured that one out, but I've seen it more than once, so I know it's a mistake that students will sometimes make. So that's a little bit of background on your coordinate plane and how to plot points. So what we're going to do now is look at some equations that only have one variable and kind of explore what that would look like. So suppose somebody were to ask you to graph the equation x equals 3. And they want you to graph it in 2 dimensions, because you could see this as a one-dimensional problem where you would just put a dot at the number 3 on the x-axis. But like assuming that you're in 2 dimensions, what does that mean? So essentially what it means is that the x coordinate for your points on this line is going to be 3, and the y coordinate actually doesn't matter. It's kind of like doing this. They've set the x coordinate at being a 3, but have not specified the y coordinate, which means it actually doesn't matter what the y coordinate is. So for instance, you might have the point 3, 0, or 3, 1, or 3, 2, or 3, negative 4. And you can also do decimals. I also want to point that out. You don't usually see that in your math classes, but you will see it a lot in your applications outside of math classes. So once in a while, we'll make sure we'll like toss you guys a problem where you're not actually plotting it on what are called the lattice points. So the lattice points are like the nice friendly spots where you can see the lines intersect. So let's say like 3, and we'll do negative 5.5 or something. So let's go see what this looks like when we go to graph it. So we have, we're going to go over to the right 3 and up nothing. So 3, 0. There's 3, 0. The next one is 3, 1. So I go over 3 and up 1, like right there. And then the next one is 3, 2. So over 3 and up 2. Now I have over 3 and down 4. 2, 3, 4. That's right there. And my last one was 3, negative 5.5, which is like right there. And what you can tell after you generate enough of these points is that this particular equation, when you go to represent it on the coordinate plane, is going to be a vertical line through x is equal to 3. And we color it in because I tell my students this all the time, that the graph is the picture of the points that make the equation true. And so there's actually an infinite number of points that will satisfy this. I mean, I picked 0, 1, 2, negative 4, negative 5.5, but I didn't have to stop there. I could have picked any of these points anywhere on that line, and I could go on like forever. And so we put these little arrows on the end that indicate that this pattern, or the points that make this true, continue upward and they continue downward. You do need to put the arrows on the end unless there is some specific reason not to. Otherwise, the arrows need to go on the end because it's the idea that there actually are an infinite number of points. And you have a lot of flexibility when you're graphing lines pick the points that you want to use. All right, so let's do one more of that type. Let's do x equals -1. And again, what that means is that you're being provided with that -1, and we have this like unknown, and you can pick whatever you want to go in there. So we could have -1, 1, -1, 7, -1, I don't know, 5. Okay, -1, -1. And we start plotting those. So -1, 1, -1, 7, 1, 2, 3, 4, 5, 6, 7, -1, 5. Oh, whoops, I did put that in the wrong spot. There we go. -1, -1. And you could keep going, but hopefully you're seeing the pattern there that this would be a vertical line through x is equal to -1. All right, let's apply this to what if we didn't have an x? What if we had a y? What if we had y equals -3? Well, it's kind of the opposite. This time you're being provided that y coordinate of -3, but the x coordinate is like up for grabs. Like nothing has been specified about the x coordinate. So you can pick whatever you want for the x coordinate. Let's go with 0. Let's go with 1. Those are nice simple numbers. When you have the choice to pick simple numbers, make sure you pick some simple numbers. Let's pick a negative number in there. We'll do -4, -3. Okay. And you can pick more numbers. You can pick fewer numbers. Totally up to you. But if I go over 0 and down 3, that's going to locate me right here. Now I'll go to the right 1 and down 3. To the right 2 and down 3, and left 1, 2, 3, 4, and down 1, 2, 3. And we could keep plotting some points, but probably what you're noticing is that these are on a horizontal line through y equals -3. And what all of the points on that line have in common is that the y coordinate of those points is -3. I'm going to do one more example and then we'll summarize this up. Suppose you had y equals 0. So just again driving that concept home. So the y coordinate is 0 and the x coordinate is up for grabs. So I'll pick 0, 0. I'll pick 1, 0. I'll pick 6, 0, and I'll pick -8, 0. And so I come over here, 0, 0 puts me at the origin, 1, 0 is right there, 6, 1, 2, 3, 4, 5, 6, I think that was 6, 1, 2, 3, 4, 5, oh, that was 5, we'll just put 5 in there too, ta-da. And then -8, 1, 2, 3, 4, 5, 6, 7, 8. And what you might notice is that this horizontal line is on the x-axis. So a little factoid. That is the equation for the x-axis. All right, quick little summary then. If you have like y, okay, if the equation is x equals a number, then it is a vertical line. And just in case there's any question, that's your vertical line. If the equation is y equals a number, then it is a horizontal line. And just to make sure we're clear on that, like that's what a horizontal line is. Sometimes those vocab words do trip students up a little bit. Now that's a little bit backwards because you think, well, y is the vertical axis, so y equals the number should be like a vertical line, and it's not. And if you blank out and you're not sure, that's where the lesson comes into play, and that's where you need to go back to the lesson and the reasoning and the thought process that went into developing that. And the better you understand that thought process, then the less likely you are to forget it or to forget it, blank out on it, or end up getting it wrong later. Again, these are not common lines. Most of the lines that we graph in algebra are going to be what we cover in the next lesson, which is an equation with an x and a y in it. But these do show up, and they show up a lot like later on in your higher level math. You're going to talk about something called vertical and horizontal asymptotes, which is like one of the most fun words ever because it sounds like you're saying something bad when you're not. So you want to have this foundation. You want to just kind of file that away and make sure you understand the reasoning behind it. So as always, I'm going to put some problems on the screen here. I'll use some lined paper this time so that you can practice with this particular concept. Great, here's what we have. So for the first two, graph the lines in each problem and find the point where they intersect. So you're going to graph x equals 6 and y equals -1, and then see where they intersect. For the second one, x is equal to 7 and y is equal to 3, and again, find where they intersect. 3 and 4 are yes, no questions. So is -3, 4 on the line x equals -3? And is -7, -4 on the line x equals -4? For number 5, write the equation for the line where the y coordinate of every point is 4. And part 6, or question 6, write the equations of the horizontal and vertical lines that go through the point 10, -6. Pause the video, work these out on a piece of paper, and then unpause the video to check your work. All right, here we go. So for the first one, we were doing the lines x equals 6 and y equals -1. So you should have a vertical line at x equals 6 and a horizontal line at y equals -1, and they intersect at the point 6, -1. For this one, we had x is equal to 7 and y is equal to 3, so we should have a vertical line at x equals 7 and a horizontal line at y equals 3, and they intersect at the point 7, 3. And you want to kind of notice that when you get down to the last problem in this problem set, because the last problem in the problem set asks you to go backwards. For number 3, is the point -3, 4 on the line x equals -3? Well, if you look at your x coordinate here, the x coordinate is -3, which means that yes, it would be on the line. For number 4, is the point -7, -4 on the line x equals -7, or x equals -4. Like that's the one that we're looking for. So should I write that over there? And here the x is equal to -7, and so no, they don't match. Write the equation of a line where every y coordinate is 4. You would just simply say y is equal to 4, and you don't specify what the x has to be. And then number 6 actually works backwards from the first ones, where you're given the point where the lines intersect, and then asked to go back and write the equation. Well, from the x coordinate here, the x coordinate is 10, so the vertical line that's going to go through that is x is equal to 10, and the y coordinate is equal to -6. So the horizontal line that's going to go through that point is y is equal to -6. So that is our lesson on horizontal and vertical lines. You want to file that away under stuff that you've been taught but probably won't see a whole lot. But when you do, you want to be able to bring it back to the forefront of your brain. And I will see you in the next lesson, where we will graph linear equations in 2 variables.